This podcast reviews how we solve for Boyle's Law. The fundamental question being asked is, how does volume relate to pressure changes? When considering Boyle's Law, we assume that temperature remains constant. The volume and pressure of a certain quantity of gas are inversely proportional. Mathematically, this can be represented by our equation where the first pressure and the first volume are equal to the second pressure and the final volume. Since they are inversely related, we can show it in the yellow box below. As you can see, as volume increases, pressure will decrease. So how does this affect objects in everyday life? Well, let's assume that we have a balloon. If we took that balloon and we ended up doubling its volume, then the gas will be cut in half of the pressure that was exerted by that gas. This is because as the volume increased, the pressure exerted by the gas had to decrease. And since these are in proportion to each other, they're inversely proportional. If you double the volume, you have to cut the pressure by half. So why does this happen? Well, remember, we're talking about gas molecules inside our balloon. They have kinetic energy, and they're always in motion. Excluding the idea that temperature, not a factor in this experiment, right? We would see that just by changing the shape of our container, the balloon, and increasing its volume, we would reduce the amount of pressure being applied by those molecules of gas. Thus, increasing the volume decreases the pressure. So we can take Boyle's law and we can use the equation P1 times V1 equals P2 times V2. And we can rearrange it to solve for the final volume. In the equation, I want to get volume, the final volume, by itself. So I have to multiply P1 times V1. And we have to divide by P2, which is the final pressure. Using our algebra skills, we can go ahead and multiply both sides by the final volume. On the right-hand side of the equation, V2 divided by V2 cancels each other out. When I rewrite the equation, we can see that the final pressure will be equal to the initial pressure times volume divided by the final volume. So let's solve some textbook examples. The first problem in the textbook says a balloon has a volume of 10 liters and a pressure of 101 kilopascals. What would be the new volume when the pressure drops to 43.0 kilopascals? Note that we have our equation. Let's substitute the values in for the variables that we have in our equation. When I read the problem, I notice I want to know what the new volume will be. So I set up the equation where I will find the final volume. In order to solve this problem, I must multiply both sides by our final pressure. So they cancel out here, and over here, we divide the multiplication of the initial pressure by the initial volume and divide it by final pressure. When we type in the calculator 101 times 10 divided by 43, we get 23.5 liters. But also note that because we have kilopascals in the numerator and kilopascals in the denominator, we end up with just liters as the final answer for our units for the final volume. If you'd like more practice solving Boyle's law, use the online tutorials on the classroom website. Look for math practice. This concludes this episode.